Hello, I'm Dr. Lonnie Herman, and welcome back to another great video here on this website about your chronic disease. Something I'm going to share with you here really not only pertains to the condition called multiple sclerosis, which is an autoimmune disease, but it just goes around for every kind of inflammatory disease, whether it's fibromyalgia or Lou Gehrig's disease or thyroid disease or neuropathy. It plays a role in every one of these chronic inflammatory degenerative diseases in the body. Now, this in particular, the research I found was directly about MS, but again, it plays a role in everything. Free radicals, you've heard of those before. Free radicals are unstable cells that create oxidative stress in the system, and the free radicals can lead to cell death. And there is a free radical that was found in some of the research called peroxynitrite. And peroxy, and you don't even have to try to say that name again, okay? It's a big word there, so let's just listen. Peroxynitrite formation within the central nervous system is, peroxynitrite formation within the central nervous system in active multiple sclerosis. And this came from a Department of Neurology and Neurosurgery in Washington University School of Medicine, St. Louis, Missouri, USA. The abstract here says, peroxynitrite generated by the reaction of nitric oxide with superoxide at sites of inflammation is a strong oxidant capable of damaging tissues and cells. Bottom line, peroxynitrite, which is a common free radical that exists in the body from different types of lifestyle stresses, is capable of damaging tissues and cells. Detection of nitrotyrosine at inflammatory sites serves as a biochemical marker for peroxynitrite. So all that says is when they found in these inflammatory tissues, they found this something called NT or nitrotyrosine. That meant when they found that, they knew that they had the free radical there. Basically, that's what that says. And the peroxynitrite mediated damage. In this study, NT or nitrotyrosine, that would allow them to find the peroxynitrite, it was detected immunohistochemically, which means in the immune system and cell testing and chemical testing, they found nitrotyrosine within autopsied central nervous system tissues from 6 of 9 multiple sclerosis patients. And in most of the MS sections displaying inflammation. So 6 of 9 MS patients, they found the nitrotyrosine, which means they found the free radical, in the tissue, in the brain or spinal cord, where the lesions are. Nitrite and nitrate, the stable oxidation products of nitric oxide and peroxynitrite, respectively, were measured in cerebral spinal fluid samples obtained from MS patients and controls. So they looked for free radicals in the spinal fluid, in the CSF of MS patients. Levels of nitrate were elevated significantly during relapses of multiple sclerosis. These data suggest that this free radical peroxynitrite formation is a major consequence produced in MS, affected CNS or central nervous system, and implicates a role for this powerful oxidant in the disease progression of multiple sclerosis. Bottom line, after all of that I said, free radicals cause tissue damage, lesions, MS, Lou Gehrig's disease. It's happening to people with other conditions like fibromyalgia. It's happening in people with strokes. It's happening with everything. It's happening with cancer too. So we have to be able to quench the free radicals. And we have to use products that have no chemicals or preservatives, have no pesticides. They're coming from a clean, pure source, so we don't try to quench the free radicals and create more in the process. You understand? So just taking an antioxidant like an alpha lipoic acid off the shelf may be doing you more harm than good. Point about this research is free radicals directly linked to the tissue, to the lesion in the brain or spinal cord in patients with multiple sclerosis. We have to get rid of those free radicals to help you regenerate your tissue and get back to normal. Yes. Free radicals and neurodegeneration. Another story, another report about multiple sclerosis. And this one comes out of a biochemical, biophysiological report in February of 2011. Departments of Molecular Cell Biology and Immunology in the VU University Medical Center in Amsterdam in the Netherlands. In their abstract, the bottom line here, it says, let me get into this point. When we have free radicals expressing in the body, it creates too much of a good thing. You see, we need these oxygen species to feed our cells. We need oxygen to feed the cell. Without oxygen, we have cell death. But when there's too much of a good thing, it can create stress and cellular damage. So the ROS here, also known as reactive oxygen species, and you could write that down and look it up, ROS, reactive oxygen species. When there's too much reactive oxygen species, cell death occurs. So in other words, when there's too much free radical expression, there becomes too much of these reactive oxygen species, and cell death will occur. Lesions in the brain. Reactive oxygen species contain one or more unpaired electrons. You're not going to have to really worry about that right now to get an understanding of this. But ROS, reactive oxygen species, initiate extensive cellular damage and tissue injury. Reactive oxygen species have been implicated in the progression of cancer, cardiovascular disease, and neurodegenerative and neuroinflammatory disorders such as multiple sclerosis. In the last decade, there has been a major interest in the involvement of reactive oxygen species and the progression of multiple sclerosis. And evidence is emerging that free radicals play a key role in the various processes underlying multiple sclerosis, or the cause of the disease of multiple sclerosis. What did I just say there? That these free radicals and too much reactive oxygen species cause multiple sclerosis. So what causes the free radicals? That's what we have to get down to, you understand? And how do we quench it? And how do we not let it happen again? To counteract the damage, we have to have certain antioxidant enzymes. The central nervous system is supposed to be equipped with this defense mechanism. But you know what happens with your lifestyle? Eating cooked foods, not taking certain digestive enzymes, your body can't produce these enzymes anymore. It's breaking down. So it's lost its ability to be able to handle too much of the reactive oxygen species and the free radicals. So what happens? They're expressing, because you've lost your own innate, inborn ability to do this because of certain lifestyle stresses and chemicals and foods and so on. The bottom line here said, we provide a comprehensive overview on the cellular origin of reactive oxygen species during neuroinflammation, as well as the detrimental effects of reactive oxygen species in processing underlying multiple sclerosis lesion development and persistence. So they found a direct connection. They found evidence that too much reactive oxygen species and free radicals leads to the development of multiple sclerosis and the persistence of the lesions in the nervous system. So what do we have to do? What is one step that we have to do? Is quench your free radicals. Stop the reactive oxygen species from causing more cellular damage and lesions. And really, this is not just about MS. We find these free radicals in cancer. We find these free radicals in fibromyalgia. We find these free radicals in Lou Gehrig's disease and rheumatoid arthritis, and the list goes on with all lupus, all chronic ailments. Okay, so we've got steps here to be able to really efficiently, quickly analyze your system and find out, does it need free radical quenchers? Does it need how much of the free radical quenchers do we need? Which one is the right one for you? Do we have to take 5 different bottles of antioxidants, or do we need just 1 or 2? How much? A teaspoon, 2 teaspoons, 10 pills, 20 pills? What does your body need to get this expression under control so you can reverse the damage on your tissues? Thank you for letting me come into your home and share this information with you. I look forward to helping you. Give us a call. Thank you.